Hey guys. Ready? All right, let's get this going. So about me, I am Joe Desimone. I've been, currently I'm a malware researcher at Endgame. And before that, I was in the security community for about 5 years. Most of that was government. And I got my BS and master's from RIT in information security and forensics. And my interests are primarily reverse engineering, threat intelligence, exploit, or endpoint hunting, and today's talk, which is going to be about exploit kits. All right, so this is the overview. And this talk is broken down into these sections. So first, it's going to be a quick primer on exploit kits. It's going to be pretty high level because there's a lot of other really good talks out there that get really into the weeds. But we'll jump right into Maxwell, which is a tool that we're releasing today, which is designed to crawl through websites and basically report on exploit kit and watering hole activity. So I'll talk about tips for configuring your virtual machines to maximize your results if you actually want to go play with this. I'll talk about some anti-researcher issues that we ran into and how to overcome them. And I'll talk about how we detect exploit activity with high confidence. And then briefly we'll talk about post-processing and the signature detection phase of Maxwell. And then finally we'll do a demo and I'll tell you where you can find the code. All right, exploit kits. So there's basically two big avenues for criminals to compromise your system. The first one is email spam, and the second one are exploit kits. So basically, email infection vectors, they require pretty significant user interaction. So they have to actually click on your attachment. Sometimes they have to open it up and click through, if it's a macro, they have to enable macros. But exploit kits, they compromise their victim after a person simply visits a website, maybe something they routinely go to. And also email providers like Gmail they're really getting pretty good at filtering out malicious emails. I don't know about you guys, but I literally cannot remember the last time I had spam in my Gmail account. They're pretty good at nuking that stuff. So most of the time, exploit kits target patched vulnerabilities. So if you keep your browser and plugins up to date, you're mostly okay. But every so often, exploit kits will have 0 days, and they can do significant harm in that short window until people get their systems patched. So the typical business model for exploit kit authors is actually malware as a service. So instead of giving you the entire code and just, hey, go kind of have fun with it, they'll basically rent out access to the exploit kit. So they'll get a login where they can go to the control panel and access it through there. They can upload their malware and view stats and stuff like that. And typically the authors will rent it out on average for $2,000 or $3,000 a month. And Kaspersky, they actually did a nice blog post about their investigation of a criminal gang behind the lurk Trojan. So basically, these lurk guys, it was kind of like a criminal enterprise. They ran it like a business, and they were basically owning the hell out of these Russian banks. And eventually, their security caught up, and they weren't profitable in what they were doing anymore. So they're like, hey, we have this great exploit kit. Let's just go sell it. So that was actually the guys behind Angler. And in order to stay in business, they're like, well, now we got to sell our nice exploit kit. And there's a decent number of exploit kits in the wild. So I'm sure some of you have probably heard of Angler, Nuclear, Neutrino, Rig, Magnitude, and Sundown. But in the last 6 months, the two most popular exploit kits actually went off the market. So Angler, Angler and Nuclear were the two. Angler due to those guys getting arrested, basically the people that were running the lurk gang. And then Nuclear, I don't honestly know what the reason was for that. There was a really great paper that got put out on Nuclear, so that could be related, but I don't know exactly why Nuclear went off the market. But basically there's this huge hole in the market share, and that resulted recently, in the last 4 or 5 months, in a surge in Rig and Neutrino exploit kit activity. So they're kind of jockeying for that top spot right now. And then, so another piece of the whole exploit kit puzzle are traffic distribution services, or gates. So basically, these are other groups of criminals. Sometimes it can be one and the same, but they go out and they try to compromise as many websites as possible. And once they're compromised, they can inject iframes into those websites. And they can basically, if you're a user of an exploit kit, you can pay these guys to say, hey, drive a bunch of traffic to my exploit kit. So they'll temporarily just, start redirecting those compromised websites, and you get a bunch of traffic in, and that'll drive up the number of infections you're getting, like as a user. All right, so talk a little bit about the infection process right now. So basically, first thing, user, they go and they browse to a legitimate web page. And basically, the browser is silently redirected to an exploit kit landing page. So this stage varies. Either the website can be compromised, like I said, with some of like the TDS and other types of players in this arena, but it can also be through malvertising. So like the exploit kit users, they can basically pay to get advertisements, and then a user will visit that web page and they just get redirected through the advertisement to the exploit kit. But after they get redirected in the third phase, basically the exploit kit will send their landing page, which basically it contains usually a whole bunch of JavaScript. It'll profile the system, basically figure out what browser you're running, what plugins you're running, all their versions, and then on the back end, they can basically determine, oh, okay, we have an exploit that matches what this guy's running, and we're going to target them. So like an example could be like an outdated Flash version. Neutrino exploit kit is a little bit different in this regard. They don't have like their own landing page. Everything's actually bundled into one Flash file, which is a little bit different than most of the other exploit kits. But so in step 4, if the user's configuration is known to be vulnerable, they'll send whatever exploit to that particular user. And user browser will go and they'll download that. So in phase 5, basically that either that Flash, Silverlight, maybe it's an IE vulnerability, whatever it is, that it'll run and gain code execution on that box. And the next step would be to actually download the payload. So this would be kind of the final step. After the exploit gains code execution, it'll go, usually beacon back to the exact same server that did the landing page. It's very rare that it would go somewhere else. But it'll basically go back to that server and say, hey, give me the payload. And pretty much always it's obfuscated in some way, either XORed or RC forward or some other technique. And that payload can be a variety of things. Most commonly now it's ransomware. It's probably by far like the most commonly used payload. But it can also be like banking Trojans, some like click fraud type or other malware. But if you're interested in like very low level details, that paper I kind of mentioned earlier, Checkpoint put out like a super in-depth paper. It was actually 2 parts on nuclear exploit kit. So it's 3 and 4 in the references. I would go, if you really want the ins and outs, go read that. So even though nuclear like isn't active right now, it still applies like all the other exploit kits. So it's a great paper. I would recommend if you're interested, go read that. All right, so here's kind of the problem. So how do we actually collect information on these exploit kits? So let's say you're interested in exploit kits and you want to track like their latest activity. As a blue teamer, maybe you want to do it to test your own defenses against like the latest and greatest threat that's in the wild. As a red teamer, maybe you want to do adversary emulation. So you actually want to like grab one of these big name kits, you want to repurpose it and test it against your customers. But how would you actually go about collecting these samples? So if you work for like a large enterprise, it's pretty easy. Your fellow employees will happily browse to the web and find their way to exploit kit activity. And as long as you have decent like snort signatures or something at the gateway, you can use your own kind of fellow employees to collect new samples and do your research that way. Now, if you're like an AV or endpoint company, it's also pretty easy. You can collect telemetry, and you're going to know like where these people are going to and how they're getting popped. So you're always collecting stuff. But what about like the rest of us here? Like, how do we collect this without really knowing much about, like, without a signature? How do we do that? Well, that's where Maxwell is going to come in. So it's basically a high interaction honeypot system, and it's designed to just continually crawl through the web, and it'll find active exploit kit or watering hole activity. So this kind of high level, basically, Maxwell, it's automated. It goes, you basically queue up as many websites as you want, and it'll basically use like full virtualization to open up Internet Explorer, whatever browser you want. But it can detect with high confidence when malicious activity actually occurs. And then it'll automatically save off the PCAP that's associated, and it'll start doing some like initial automated analysis on it to figure out which exploit kit was responsible, like what IPs, what domains are involved, and more. All right, now I'm going to start kind of talking a little more in the weeds about Maxwell's architecture. So really it's broken down into these 4 main components. Basically inside the virtual machine, there are Python scripts and an instrumentation library for collecting data. And then outside of the VMs, there's some other, like there's a controller script to manage VMs and jobs, and then there's also a result collection script. to actually process the data that comes out of the VM. It's really kind of purpose-built. I didn't want it to be, too complicated. It's not a whole lot of lines of code. It's very specific for this job. So I know there's a lot of sandboxes out there, but, it's easier to understand than if you try to dig into maybe some other exploit kits that are, tens of thousands of lines of code. And I also had some awesome input. So Endgame has some sweet DevOps engineers, and they're basically when I started there, they're like, hey, I had this idea. They're like, no, you're doing that all wrong. You gotta bring the DevOps with you. So that kind of bled into the design. And if you really want, you could scale this out, this architecture out to hundreds or even thousands of machines, no problem. All right, so this is kind of a diagram overall of how we design Maxwell. It's super high level, but you can kind of see, well, first, I have no GIF for doing diagrams. This is literally Visual Studio icons from the 90s. But basically, you got the central server there, this is kind of like the conductor, like the brains of the operation. So the way you have it set up right now, it'll connect into a vSphere server. Now, you could easily drop in other, you could modify the code to change that to do VirtualBox or some other type of virtualization software. But basically, it'll connect in there and use that to spin up and down VMs. And then events will stream directly out of the virtual machines directly to a RabbitMQ server. And then also on that central server, there's another script running that'll basically consume those events. And it'll basically monitor and wait for something malicious to happen. And if it is, then it'll shove it off to Elasticsearch. That's kind of like the back-end permanent storage of malicious artifacts. All right, so inside the virtual machine, we've got some VM agent scripts. So this is a really small Python script. It just sits there, it listens, it waits for a job file to be sent into the virtual machine, and it reads it, and basically it's the high-level configuration, what is this job going to do? And basically I wanted that to be really simple, so I didn't have to keep on recreating new snapshots in my virtual machines when I'm doing development. I just kind of want that snapshot to be a more permanent kind of thing, and then the more complicated code that has bugs or whatever, I can easily just push it in at runtime. And then there's also a named pipe server. So basically, every process that gets the instrumentation library will connect to this named pipe server, which basically just receives all the events and then forwards it directly out of the virtual machine to the RabbitMQ server. And there's a whitelisting there with the named pipe server, where basically every message that comes in, it'll check it against the whitelist. That way, you don't get crazy amounts of noise. It's a major problem with a lot of other sandboxes. It's a ridiculous amount of events that happen, and you kind of don't know whether or not that's actually bad, or is that something that normally happens. Well, we'll get into that a little more later, but this is kind of an example of what the whitelist might look like. So basically, the whitelist is configurable. It's just a text file. It's kind of looks like JSON, but basically, so there's key value pairs for the event, and you can kind of set up your own rules to say, hey, if it matches this. If the value for this key matches, then you can filter it out. And you can do, a 0 would be a string equals, a 1 would just be a string contains, and you can even do regexes. So you can even, do multiple rules, in one line, and it basically will just and everything together. So, the goal is you want it to be, you don't want to, whitelist out potential malicious activity, but you don't want to have 1,000 rules in here to filter out everything. So you need kind of a healthy balance. But basically, the first example on there, it's filter events where the function name is ntWriteFile and the file name.
Hi folks, I'm Geek here. Unfortunately, once again, the advert medias have caused me more pain in my life and the bane of my existence. So we will actually have the audio to about the 21-minute, 30-second mark. I apologize for the inconvenience, but the talk will resume then. Sorry.
the exploit kits themselves, they have tons of randomization built in. So like you look at it and you're like, what the hell? It's like all these, words. They'll basically select like from a dictionary of like 500 words in order to randomly generate their the actual Git and the Git requests throughout the exploitation process. But what I'd recommend is taking certain samples across a period of time and just trying to figure out what's common, because they do make mistakes and there are things that are common, and I'll talk about that a little more. But basically, that's a decent way to do it. Also, a lot of people don't dig too much into the exploits themselves, but even like on Flash, I like to write my signatures on the actual Flash files. So like free Flash decompiler is great. I'll just fire that up. I'll take a look at like maybe 2 Flash files side by side and be like, oh, this kind of visually looks similar with like this decryption routine. So I can kind of look at like you can select and output the code bytes, and I'm just like, okay, well, these bytes are similar here, and you can write your signature. And those have proven to be really valuable and last for a long period of time. And you should definitely also follow like these guys on Twitter and check out their blogs. So this is what I use. Like, hey, I've got some random activity. I don't know what exploit kit it is. I can go to these their websites and kind of look at their samples and compare it to what I'm seeing and be like, oh, this looks like the exact thing they were calling neutrino or they were calling rig or magnitude. And that's how you can kind of build out and understand like what's really happening. All right, so putting it all together, how do you actually take this code and make some use out of it? Basically, first step, get your infrastructure up and running. So like I said, we use vSphere. There's really no reason that you can't even like put this on some cloud architecture somewhere. Just probably be aware of like whatever terms of service you're running for that cloud provider. RabbitMQ and Elasticsearch are super easy to set up, so I'm not really going to go into the details. I will say that I like Ubuntu. I use that for the controller server. But I guess we should probably talk about like what websites to actually push into this thing, what to queue up. And a surprisingly effective technique is actually I take the Alexa top 25,000, 100,000 domains, and I'll just shove them in there, and you will find bad stuff. Even if you have like 3 or 4 VMs running, you can find stuff. And a trick to kind of like accelerate the amount of websites you can go through is just you can do like 5 websites for each job that you run. So instead of just think of the virtual machine running, IE opens up, it's sitting there for a timeout period, and it closes out. You can just open up 5 websites, and then you're getting 5 times basically the throughput on the number of websites you can analyze. The only problem with that is once you get the final output, you're like, okay, one of those 5 websites is bad, and you kind of have to manually go through the PCAP to figure it out. Or if you have a super good anonymizing service, you can just resubmit each 5, and then because you get re-popped with your new IP. But it's probably also a good idea to like revisit old websites that like once you find something that are popped, because a lot of times if they're compromised, like they'll keep on serving exploits for days, weeks at a time. I mean, like the backend, all the infrastructure is changing, but like what they have compromised doesn't change. All right, now I'm going to try demo. So I do not believe in the demo god, so I did a video. Yep. But I'll kind of show you guys, what? Oh, am I not mirrored? Oh, yikes. Does anyone know how to mirror? So I can like... Yes, they do. I'm kind of a Mac noob. Yeah.
You guys see this? Is it peeking out? Is it peeking out?
Ah.
Now, the problem is I have no idea how... Oh, wait. You're not
Can I just mirror? Yeah, exactly. Yeah, do I just mirror? Display.
That's all right.
Show mirroring options in the menu bar when available. Not available. Oh, there you go.
Yep.
Whoa, look at that.
There you go.
All right, so I am definitely going to preface this. I literally went through W3 schools to develop some of the web front end on this. So, like, you guys, I apologize in advance. But basically, so initially, I had no results in my little dashboard that I put together. Oh, this is awful. Holy shit. Oh, my God. So I do have a fallback. I have some screenshots, which are shitty, but I could show them. Do it live. Yep, yeah, you can't see anything. So basically, I'll just kind of walk through what I did briefly, and then I'll show you some screenshots. Basically, so on the left, I had the actual output from the controller. So basically, it's spinning up and down virtual machines. And then I had, queued up probably 50,000 websites. But I can go in and I can queue a new website with a higher priority, and it'll automatically jump right to it. So I just went in. I knew of a compromised website, so I put that in. And basically, within probably 5 seconds of that new job being executed, there was, you get all the output from the virtual machine just being streamed back to the results console, and that's just being dumped into Elasticsearch backend. So let's just skip through all that. All right, yeah, that's garbage. All right, so go into the backup screenshots. Oh, fuck. Weird. No. All right, can you guys see this? All right, can you guys see this? All right, so I'm going to try to do this from memory, but because I can't see it at all. So basically, actually, we'll start with this. Post-processing. Is that right? All right, so this is kind of like post-processing output you get. So this one actually hit on an afraid gate signature that I had, and it'll show you like the IP that it received it from, and it'll even, I just kind of do like a grouping regex. So afraid gate, basically they do like a document write, and for whatever reason, like their iframe, they have like they'll do an I plus frame, so I just have a signature written for that. So if I ever see that in the PCAP, then I just pull out that whole thing and I'm like, boom, afraid gate. And then for Neutrino, like they do, for whatever reason, their user agents they use are always Media Center PC. And it's been like that for as long as I can remember. I don't know why. It's super easy to signature. How many people, yeah, go ahead. So to be honest, like I haven't been running this like in the last couple months, but I would say like in the top 25,000 like domains, I'll see at least like maybe 2 or 3 a day that are compromised, at least. And that's kind of without great like obfuscation like my IPs. Like I know they're probably detecting some of my activity, so there's probably more than that. But I mean, there's pretty popular websites sometimes get popped and they're detected by this. So it's, yeah, does that kind of answer your question? So it'll pull out the GET request, the actual payload, and it'll label it, hey, this is Neutrino because this GET request looks really familiar to me. And you can see there's the host name in there. I gotta go back one. And then this is kind of the output of the event. So right at the top, you can actually see there's like a VM detect kind of in the middle of the top line. So this one was actually looking for ESET, like NOD32 antivirus, and we detected that. So that was an event that came right out. So even if they don't target like the exploit, we have that event, like it will still flag on it. It was also looking for Fiddler. And then we have a guard page violation. So you can see what it basically tells you is the source and the destination module for that guard page violation. And basically it's saying Flash was trying to read from Flash, which is kind of weird, and that doesn't normally happen. And that's actually because of their read primitive. So they were basically going through memory trying to find like the target routine that they wanted to locate. So it caught it in that regard. And then the next guard page was basically the shellcode routine. So it kind of looks like a funky, iexplorer.exe, EAF, and some basically the address that it caught it at. But that gets saved out, and we can run. On my demo, I had a YAR rule. It basically, you could log on those actual shellcode routines, even narrow down what the exploit kit is. And then after that, you can see, since this was Neutrino, what Neutrino really likes to do is they'll basically just create a new command process, and they'll echo like this giant command to a new script, and they'll basically execute WScript on it, and that's what actually goes out and downloads the payload. And the payload is also RC4 encrypted. So in both that echo event and in the create process before, you can see the RC4 key that they actually use and the full URL that they use to pull down that payload. So you can take that, you can decrypt that payload if you want. This was actually like the 3rd time I ran this, and for whatever reason it like crashed or something, but this was actually Locky ransomware. So on the other two runs, when it would run, you basically get, so there's like 60 events that kind of occurred through this. But when Locky or something runs, it just like hammers the crap out of the VM. There's like 600 events. Basically, you can see it going through, encrypting all the files, like adding, this was a ZEP2 variant of it, so you can see all the file name extensions, basically. Generally, you can tell if something went horribly wrong. And it's probably worth mentioning, one of the, and I don't know if I mentioned this, but one of the design decisions was to not basically have all the events like accumulate in the VM and then pull them out after the job is over. Because if you have some really nasty ransomware that like destroys your VM, and this totally happened to me, then you lose like all your analysis. So basically what you want to do is, as things are like, as the events are happening in the virtual machine, you want to be saving those off and just streaming them out. So even if the whole thing falls over, you still at least got up to that point of events in order to figure out what the heck happened. So yeah, I think that's probably good for the demo, or lack thereof. So kind of in summary, so Maxwell, so what we presented here, it's basically a system that allows you to crawl through the web in a fully automated way. It can do detections of exploit kits. Watering holes too, I would say, you know, if you're a really sophisticated adversary, like you're not going to be blacklisting, you're going to be whitelisting your targets. So like you'd want to run this on your corporate network or route the traffic through it, so that if someone was going after, you know, like your enterprise, then you'd still catch that activity. But also, if you know anyone in the audience, like if you thought this was cool, have any ideas like how we could improve it, or want to like collaborate on stuff, then hit me up after the talk or send me a message on Twitter. I'd definitely be glad to hear from you. And kind of for the red teamers, I know it's a red team heavy audience. If you don't have like web exploitation in your bag of tools, you might want to think about doing it. You know, it could be a good wake-up call for some of your customers if they're not the best at patch management. You can catch them off guard with one of these payloads. And you could say, hey, like we popped you with, you know, repurposed neutrino or repurposed rig. Like you could, like this is like really bad. This could have been Locky ransomware, and you guys would have been boned. So it kind of be like a, you know, important thing to show your customers. Like you guys should really update your stuff. And the code, I'll be posting it today. It's basically on our Endgame GitHub account, and it's going to be MIT licensed. You can pretty much do whatever you want with it. And here's some references. So definitely standing on the shoulders of giants out there. There's a lot of really good work done in this field. Palo Alto, you know, Kaspersky even, Checkpoint, Malware Don't Need Coffee, Malwarebytes, Trend Micro, Twitter guys on there. So thank you to all these people that helped me out. And some image credit. Questions? Yes. So the question was, why am I not running it in several months? So I just been really busy working on other projects. This was like a really fun like research project, and then I kind of just got distracted and was like, oh, some other shiny object just kind of kept me over here. So that's just, there was no particular reason other than that. Any other questions? Yep. Yeah. Yeah, actually, so you can go in the config file for like vSphere. You can actually disable certain things that they look for. Like, I could probably, you know, send it to you, but there's like a list of configuration options that I can dump into like the VMware config file that hardens it against those sort of things. But definitely like no VMware tools, like, and keep like security, like Wireshark, Fiddler, like, I mean, if you don't need it in your VM, like don't install it. But I mean, in reality, like if they really want to catch you, they will. But it's at what point do they catch you? Like if they are just able to fingerprint you in JavaScript, it's pretty easy to evade that detection. But like yeah, if they're doing it like in their shellcode or something, that would kind of suck. But yeah, hopefully that answers your question. Anyone else? Yep. Yep. The question is, how do I automate a whole bunch of URLs? So basically, there's a script. You can literally give it a text file and say, hey, like here's a text file with like a list of websites, and it'll just add it into the queue. And you can have like your army of like 20 virtual machines that'll just start pounding on that. Yeah, they published, it's old, but they published their top 1 million domains. So you can go download that. Some of the websites like aren't even legit anymore, like they don't load, but it's, I mean, I use it and it works. So yeah, it's freely available though. Thank you. Anyone else? Thank you.